Hello viewers, before we actually start with the program, just have a quick glance at some of the electronic gadgets which we suppose you're quite familiar with. Well, all these gadgets have a passive component which is most widely used in electronic circuits. In the electronic items you have seen just now, their circuit assembly consists of an array of small components. A large number of these components are resistors. That is what exactly this program is about. The flow of current through a conductor encounters an opposing force known as resistance, and the component that is specifically designed to exhibit this property is called a resistor. Symbolically, a resistor is represented like this. You know that a dam checks the flow of water and helps in avoiding floods. Similarly, a resistor in an electronic circuit checks the flow of current. The resistance of a conductor R is the ratio of voltage V to current I. Resistance, which is a measurable property of a resistor, is measured in ohms. Some of the important characteristics of resistors which are of concern to users are tolerance, temperature coefficient, wattage, stability and frequency effects. To manufacture resistors of exact standard value is quite difficult, but still the resistors are available in certain values of tolerances. The tolerance values normally available are plus minus 20%, plus minus 10%, plus minus 5 and plus minus 1%. However, precision resistors can be made accurate to plus minus 0.25% to plus minus 0.05% or if desired up to plus minus 0.01%. Temperature coefficient is defined as 1 by R del R by del T and is expressed in parts per million per degree Celsius. Wattage is also referred to as power rating. It is determined by the power which it is able to dissipate without greatly changing its resistance. The relative sizes of all resistors change with wattage. Stability deals with change in resistance value following exposure to specified environmental stages. The resistors can be subjected to stress due to temperature changes during storage, application to full rated power, short time overload, and radiation exposure. Frequency response of a resistor is affected by distributed capacitances, lead inductance, skin effect, and dielectric losses. For a given type of resistor, the frequency response tends to improve as the resistance value is lowered and the case size is decreased. Well, these were some of the important characteristics of resistors, and now we come to different types of resistors. Resistors are of three types: variable, fixed, and special. However, they belong to either of the two classes, variable or fixed in their value. In electronic circuits, it sometimes becomes necessary to adjust the values of current and voltage. For example, it is often desired to change the volume or loudness of sound, the bright television picture, etc. Such adjustments are done by using variable resistors. A variable resistor is also referred to as a potentiometer, commonly known as pot. Basically, there are three types of pots: single turn, multi-turn, and trimmer. Single turn pots are available in resistance range from 50 ohms to 0.5 mega ohm in tolerances of plus minus 10% and plus minus 20% and in power ratings up to 3 watts. In a TV receiver, these pots are used for brightness and contrast controls, whereas in an amplifier, the single turn pot is used for the purpose of gain control. Multi-turn pots generally have 10 or more turns. These pots have resistance range of 50 ohm to 250 kilo ohm with a tolerance of plus minus 3% and power ratings up to 5 watts. These are used in applications that require precise setting of a resistance value. Trimmer pot is used as set me and forget me pot. Hence, these pots are usually set of resistance. Trimmer pots are available as single and multi-turn units. These pots have a resistance range from a few ohms to 5 mega ohms with tolerance plus minus 10% and power rating up to 1 watt. Four basic types of materials are used in the construction of pots: carbon, CERMET, conductive plastic, and resistive wire. All these materials are used for making resistance element. Let us now observe the manufacturing of carbon pots in a factory. First of all, a mica strip of a size depending upon the cutting die is coated with carbon resin. Carbon resin mix is prepared by stirring black pigment, ethyl glycol, trichloroethane, and a hardener apart from other ingredients like varnish, graphite, epoxy resin, etc. for 24 hours or more. Carbon coating is done with the help of a screen printing machine. After this, the strip is then placed on a conveyor belt. The strip passes through different heat chambers held at 3 different temperatures. The baked strip is placed on the screen printing machine again for depositing silver layer at the contact points. Now the strip again passes through the heat chambers for the purpose of drying. A cutting machine helps in cutting the final strip according to the required specifications. The value of each piece is then tested, which ought to be within the specified tolerance range. The sorting of pieces is also done at this stage. The finally selected pieces are then tacked with the help of a pneumatic riveting machine. After riveting, a slider and a spindle are fixed to it. Once assembled, this carbon pot is ready for marketing. We hope you have enjoyed the journey of this pot through its various stages of manufacturing. Let us now summarize what we have learnt so far. Resistance R of a conductor is the ratio of voltage V to current I. Resistance is measured in ohms. Some of the characteristics of resistors are tolerance, temperature coefficient, wattage, stability and frequency effects. Resistors are of 3 types: variable, fixed and special. Variable resistors, commonly known as pots, are of 3 types: single-turn, multi-turn and trimmer. Construction material used in the manufacturing of pots includes carbon, CERMET, conductive plastic and resistive wire. In the next program of the series, we will deal with fixed and special type of resistors. Till then, goodbye.